So in this video, we will be looking into the conversion of a binary number to hexadecimal number. In the previous video, you saw the conversion of an octal number to binary. So if you have missed it, you can check it out. In this video, we will be learning to convert three different types of binary numbers to hexadecimal numbers. So as you can see on the screen, we have three different types of binary numbers. The first one is a plain integer binary number. The second one is a fractional binary number. And the third one is a combination of both. So before we start the conversion process, let's see the conversion table between binary and hexadecimal numbers. So as you can see on the screen, we have the binary numbers and its equivalent hexadecimal numbers. Now we know that the base and radix value of hexadecimal number system is 16. So as you can see in the table, we have 16 different symbols of hexadecimal numbers and equivalent binary numbers. Now the first 10 values of hexadecimal numbers are plain numbers, that is 0 through 9. But the remaining 6 values of hexadecimal numbers are alphabets with their corresponding binary equivalents. Keep this table in mind as we will need these values when we convert from binary to hexadecimal numbers. Okay, so let's move on to the first question. So as you can see on the screen, the first question consists of a plain integer binary number which needs to be converted to the hexadecimal number. So here's how we go about the solution. First, write down the entire binary number, leaving some spaces in between. Now starting from the right to left, we make pairs of 4 digits. That is, this will be the first pair and this will be the second pair. Now after you make pairs, we convert these pairs to their corresponding hexadecimal values. So this pair will be converted to an individual hexadecimal value and this pair will be converted to its corresponding hexadecimal value. So according to the table that we just saw, 0010 corresponds to 2 in hexadecimal and 1101 corresponds to number 13, but in hexadecimal 13 is equivalent to D. So now that we've converted these individual pairs to their corresponding hexadecimal values, to get the final answer we just need to club these values. That is 1101 0010 in binary is equivalent to D2 in hexadecimal. Now let's move on to question number 2. Now the question number 2 consists of a fractional binary number. So in this case we are only interested in the fractional part. So let's first write down the question. Now in case of fractional values, we start making pairs from left to right of the decimal point. So here 1011 will be the first pair and 101 with an additional 0 just for pairing purpose will be the second pair. Now this 0 doesn't have any positional value, it's just for the pairing purpose. So now as we did in the question number 1, we first convert these pairs to its hexadecimal equivalents. Now according to the conversion table, we know 1011 corresponds to 11, which in hexadecimal corresponds to B, and 1010 corresponds to 10, which again in hexadecimal corresponds to value A. So now to get the final value, we just need to club these two values, that is 0.1011101 in binary is equivalent to BA in hexadecimal. Now let's go ahead with question number 3. Now as you can see in this question, we have an integer part as well as a fractional part. So this is a combination of the question number 1 and 2. So let's write down the question first. Now for the integer part, we make pairs of 4 starting from right to left of the decimal point. And for the fractional part, we start making pairs starting from left to right of the decimal point. So for the integer part, this would be our first pair and the second pair would be this one with 2 additional zeros which are just for the pairing purpose. For the fractional part, this would be our first pair and since there is only 1 0 remaining, we add 3 more zeros for pairing purpose, which makes this a second pair. Now we need to convert these pairs to the individual hexadecimal values. So we know 1101 corresponds to 13, which in hexadecimal is equivalent to D. 0011 corresponds to 3 in hexadecimal, 0111 corresponds to 7 in hexadecimal, and 4 times 0 is equal to 0 in hexadecimal. So now we have got individual values and for the final value we just need to club these values. So the final answer would be the entire question, which is equal to 3D.70.